Hi everyone. Today we'll talk to you about Newton's third law of motion. I don't know about you, but when I came across this law the first time, I was absolutely baffled and it took me a long time to figure out what exactly is happening. The way I looked at it is, if every force that I apply on any object applies the same force back at me, I should be moving backwards. Of course, that object would be moving forwards, but what that means is as soon as the object moves forward and I move backwards, the contact is lost. So my ability to push anything is finite and limited. But in real life, I do see myself effortlessly pushing, like furniture around, chairs or tables in classrooms, and it's never a case that I'm losing contact with the object. So I started to think, and I was quite confused as to why this is happening. So I thought I'd kind of take the next few minutes to explain to you what exactly is happening. So if you have a block of wood, and let us kind of work with a block of wood, right? This is myself. Not a great artist, but I'm going to basically show you graphically represent what's happening. There's a force which I'm applying to the block of wood to push it in this direction. And let us see what's going to happen. Now this is of course the floor. The wood applies a downward pressure which results in a friction in this direction, which is Fw. Similarly, the force the wood is applying on me is creating a friction which is applying in the opposite direction, which would be in this direction, which is Fm. So if I just isolate the two objects, there's a wood. In the wood, what happens is we have F, me on wood, going in this direction, minus F Wm, which is a force which is applied in this direction, hence the minus. If that is greater than 0, the block of wood will move in this direction. Or Fmw has to be greater than it's just the friction, right? Fw, which means it has to be greater than the coefficient of friction of the wood on the floor multiplied by the mass of the wood multiplied by gravity. These two essentially generates the weight. Now if I can pause and ask myself what will happen when I actually apply on the person, that is me. On myself, the forces, now I will need to stop moving in this direction, which means my force that is applied to me, which is force M, which is the friction force which is applied in this direction, right, minus the force which is on the wood on me, which is applied in this direction, right, must be greater than 0 for me to able to move in this direction, which means Fm, that means the friction, must be greater than Fwm, right? Now we know this is equal to C, the coefficient of friction of myself on the floor, into mass of myself into gravity must be greater than Fwm. So if I take this formula that we found out here and we combine it with this formula, what do we get? We know that Fmw is equal to Fwm by third law. So let's write that down. By third law, Fmw is equal to Fwm, right? Therefore, what we can say is, combining these two, what we see is, if C of M into M of M into G is greater than C of W, M of W into G. If this is happening, then we will all move in this direction. What does it mean if I cancel this out? So we have C M upon MM must be greater than CW MW. So this gives you an indication how myself, say at 40 kgs, could potentially move an object which is 80 kgs. And the way I do it is, if I can figure out a way to increase my CM tremendously and reduce this CW, I can actually make this equation work. Right? So, how can we do that? So, look at it in real terms. We often see, if we put ourselves on skates and try to push the same object, we do tend sometimes to move backwards, because what we are doing is, we are actually doing exactly the opposite. We are trying to reduce our coefficient of friction. However, if we wear some good shoes, which is very sticky and sticks to the ground, we are actually able to increase it. And if, for example, we are able to put a layer of oil or water, which reduces this, we can again move. So the third law does not prevent me from pushing an object, so long I understand the dynamics and we can take action. So the thing that we have to do, and you possibly do it yourself, we have to make sure that our coefficient of friction is high, and we would like to see that the coefficient of friction of the object that we are pushing is low. So the easier one that we know from practical experience is, if you put that block of wood on wheels. On wheels, we now have rolling friction, and which is much lower than the static friction, and we know in that case it's so much easier to push something around. Right? However, if this was not a floor, but if we were sitting on ice, then you will have the situation that I started to talk about. There's no friction here. Every time I push a block of wood, I will move backwards. If you have access to an ice skating rink, or even, for example, a roller skating, you will realize how this works. So Newton's law of motion, third law of motion, does not prevent me to push, doesn't prevent people from moving around, because we have this concept of friction. Thank you. I hope you found this interesting, and tomorrow we'll talk about a lot more examples of how to make Newton's third law of motion make sense in some of the things that we witness around us in real life. Thank you so much.